Today I'll be covering the review for Unit 7 on matrices and systems of equations. So question 1 asks us to use substitution or elimination to solve the system. I'm going to use elimination in this example, but you can do either method. So for elimination, I'm going to take this bottom equation and multiply it by 3. So 3 times everything is going to give me 3x plus 15y equals 66. And I'll also have my other equation as it is. So then what I can do with these two equations, once I have them, is to add them together. Once I add them, you will notice that the x's do get eliminated. So the 3x's go away, so you're left with 0x plus 19y equals 95. If I divide this by 19, I get y equals 5. So that's great. I have y. Remember, for a system of equations, I also need x. So what I can do with this 5 is plug it in right there for y. It's going to tell me that x plus 5 times 5 equals 22. So x plus 25 equals 22. And subtracting 25, you get x equals minus 3. Right? That is the method with elimination. Fairly straightforward. If you want to try substitution, you will get the same answer. I suggest solving the bottom equation first for x if you're going to take that route. Alright, so moving on to question number 2. We have two systems. We want to know which one has no solutions. So in order for there to be no solutions, for no solutions, when you're solving this, you must finish with a false statement. So oftentimes they'll take the form of two different numbers that are equal to each other, which are not actually equal to each other. So for example, you get something like 14 equals 15, or 0 equals 24, something like that. Some sort of false statement will give you the one that has no solutions. So if you go through and try this, you will find that B is the one with the false statement at the end. Because A will end with 0 equals 0. It's a true statement. That will give you infinite solutions. Right? And on to question 3. It asks us to write but not solve a system of equations that could be used to solve the following scenario. 2 t-shirts and a sweater cost $60. 1 t-shirt and 2 sweaters cost $75. How much does each item cost? So we can just say x is t-shirts, y is sweaters. It is useful to define our variables so we know which one's which. And so the people we're communicating know which one's which. So we have 2 times t-shirts plus 1 sweater equals $60. We also have 1 t-shirt plus 2 sweaters equals $75. There's our system of equations right there. Both of those must be true at the same time, so therefore that is all we need to do. That is our system. Right? For number 4, we're starting to go into matrices now. So we have 2 times matrix A minus matrix B. Right, so for this, 2 times A is going to be 2, 0, minus 4, 6, 4, and minus 2. All we do is double everything inside of there, and we want to subtract B. So 0, 5, 3, minus 2, 1, and 2. And now we can just subtract element by element. So 2 minus 0 is 2, 0 minus 5 is negative 5. Negative 4 minus 3 is negative 7. 6 minus negative 2 is 8. 4 minus 1 is 3. And negative 2 minus 2 is negative 4. Right? Sometimes in example 5 we cannot add two matrices because in order for us to do that they must be the same size. They must have the same dimensions. They must be, for example, a 2 by 3 and a 2 by 3. In our example here we have a 2 by 3 and a 3 by 2. We cannot add because they are not the same size. For adding and subtracting you need the same size. For multiply and divide, the number of columns in the first matrix must match the number of rows in the second matrix. Right? So that is the front side of the review. We'll move on to the back side with question number 6. It says you may use a calculator or iPad on this page. The Desmos Matrix Calculator is located at desmos.com/matrix, which means that for multiplication you may use the Desmos calculator for that. Keep in mind that if you're going to multiply by hand, you're going to do it row times column. So row, if you wanted to find row 1, column 1 of the multiplied matrix, you need to multiply row 1 from A, column 1 from B, so on and so forth. Desmos will do this for you, so if you would like to try it by hand, you can. Otherwise, you can plug it into Desmos Matrix Calculator and then type in A times B, and you will get negative 35, negative 17, negative 12, and negative 8. Right. And then for question 7, we want to take this system and express it in matrix form, which means we're going to take all the coefficients of our system and plug them into a 3 by 3 matrix because we have 3 variables and 3 equations. So we have minus 3, 4, 2, and then we have 2, 1, negative 1, 1, minus 2, 3. So that's matrix A. We also have the column matrix of our variables. So x, y, and z, that's the x matrix. The variable matrix, so that's x. That's going to equal matrix B, which will be the constant matrix on the right side of our system. It's also a column. It's a column of 17, 0, and minus 4. Right, so in part B, it wants us to use technology to solve the system. So if we set up our matrix equations AX equals B, we need to multiply by A inverse on both sides to get the X matrix by itself, the variable matrix by itself. So we'll make sure it is on the left. That is important. Right multiplication will be something different. Right, so X equals A inverse B. So this right here, A inverse B, is what we want to plug into Desmos. So we have our A and our B matrix from part A. We can plug those into Desmos, type in A inverse B. That will give us the matrix of negative 1, 3, 1. A 3-row by 1-column matrix. So that will tell us X equals negative 1, 3 equals, or Y equals 3, rather, and Z equals 1. They are this way because of how we wrote it. We wrote X, Y, and Z purposefully in order so that it came out and read out nicely like that for us. Right? So if you have questions for us, please let us know. Otherwise, that is the end of the video.